All right, so IPv6 in Wireshark. So again, I'm going to talk a little bit about some basics of V6 and Wireshark and kind of go through a few more things after that. So one of the things I like to start out with in my V6 presentations is a little bit of history, because it actually, I think, helps people understand why somebody like me would get excited about some of this V6 stuff when we kind of sort of have its counterpart in V4, and a lot of people say, so what's the big deal? So we'll talk about that, talk a little bit about some of the key components in V6. And the clicker doesn't click. What else is happening today? So history. This whole thing started back in the early 90s. Who was doing networking in the early 90s? Come on, old folks. Fess up, all right? And if you're doing IP, which we now have to say IPv4, in the early 90s, everything was statically, manually configured. We had no automagic anything. DHCP didn't exist. NAT didn't exist. RFC 1918 private addresses didn't exist. Everything was public addresses. And so at that time, the grand poobahs of the internet kind of said, you know what? 4.2 billion addresses, 4.3 billion addresses are going to run out probably in the early 2000s if we keep doing what we're doing. So let's come up with something else. And they chartered some groups to go off and work on what they called IPNG, IP Next Generation. Now in that process, they said, we still got to fix our current problem. And so a couple of other transition technologies were developed. DHCP, automatic addressing. Woohoo! If you were there in the time, that was like the pinnacle of everything. Just life got so much better. All right? And then we came up with things like network address translation, and then private addressing. And the world in networking just completely changed almost overnight with all that stuff. Now we had auto addressing. Now our numbering scheme had more life because we didn't have to deal with public numbers, quote unquote public numbers, on the inside of our networks. We could do this private numbering. And all along was this churning. The V6 or the IPNG task force was chartered to do all that kind of stuff in this next generation protocol. So by the time V6 got ratified in the late 90s, it became one of those, duh, we don't need this anymore. We got it in V4. So V6 has languished for the last 15 years, but we're getting closer to where we're going to have to get there. But a lot of that stuff that V6 has that looks really cool, we kind of have its counterparts. The last little bit was known as the IPV6 addressing back in the mid-2000s, and that's that 169.254 address that Windows or Microsoft started with Windows XP. Let's build an automatic IP addressing configuration schema so we can just plug up some computers together in a common layer 2 domain, and they talk, all right? But what happens to the IPV6 address if a V4 client gets a DHCP address or a manually entered address? Where does that IPV6 address go? It vanishes, all right? It does not in V6. It has the same concept as the IPV6, known as the linked local, and it does not go away. This is your first little tidbit if you've not done a lot of the V6. So we have to have the quintessential slide, and today it was really great. We have 10 to the 21st transistors in the world. Is there anything bigger? Yes, everyone's got a V6 address, plus we still have more left. And so I tweeted that saying basically this morning, all right? Transistors are catching up, but V6 has still got more addresses, because we got 10 to the 30. I've got 340 undecillion. That's bigger than a Z or whatever, right? Yeehaw! But it's catching up, right? The transistors are catching up. So we have all that good stuff, the grain of sand, all the weight. It basically going from a V4 number now is this big, all right? And a V6 number is this big, all right? That's kind of the fun bit about it. Some of the other things about it, it's 32-bit V4, 128 V6, and everybody wigs out with this, oh my goodness, I'll never remember this big honking number, all right? Well, don't worry about it. It gets easy really, really, really quick. The biggest problem I find in V6 is this colon character. What is with the colon? It's a shifted character for us in the US. I now have to say this, because some keyboards it's not a shifted character. But most of the keyboards we're going to deal with, it's a shifted character. I can pretty much guarantee, as you start playing with V6, you're going to end up with dots instead of colons, and in your V4 addresses, you're going to end up occasionally with colons instead of dots. All right? It's inevitable. And then after a while, you'll get going. There's actually a company in Europe or UK called IPV6 Buddy that make a little USB keypad. It's got colon, double colon, hex characters. It's all everything in one. And I found that I had gotten so used to the shift for the colon now that the external keyboard actually doesn't help me. But it just takes a bit. It's like anything else to play with it. So out of the 128-bit address, it's broken up into 8 components known as either quibbles or hextet. Now, quibble stands for quad nibble. Each one of these 4 bits of the 16 is known as a nibble. So you have 4 nibbles, quad nibble, hence quibble, or hextet. And those are the 2 favored values, with hextet being the most favored. The downside is hextet's not numerically correct. It's really a hexadectet, but that's hard to say. And I'm from Texas, and we got to add extra syllables to every word anyway, all right? So hextet's more the favored according to the RFC. Whatever you call it, it doesn't matter, but hextet, octets for V4, hextet for V6, it kind of goes. So each 16 bits is divided by a colon. You got 8 groupings or 8 hextets. You got a 128-bit number. So far, so good? And it's hex, so who remembers IPX and Apple Talk networking days where we had domains or networks with names, right? And so we've got, 6 Lab, Foosball, and Dallas. Now, you should not put words in your production network addresses because the bad guys are going to test dictionary attacks on that first, right? Because it's hex, it's limited in scope, right? So they're fine for labs, they're fine for fun, but Facebook even does it in their production. In their 5th and 6th hextets, it's Facebook, F-A-C-E-B-O-O-C. But they didn't ask Jeff, they don't care, right? Everybody knows it anyway. So just know it's fun, but leave it at the fun factor and not in the we're going to use it factor. Now, the 128-bit address gets very easy to understand at a network segment or a VLAN or however you kind of want to refer to that. But on an endpoint segment, whether it's desktops, laptops, phones, printers, servers, whatever, on a quote-unquote, I'll just say VLAN, everybody okay with this, all right? At a using point VLAN, the setup is the network prefix is the first 64 bits, and the interface ID, which is the official name we would call the host ID, is the other 64 bits. All right? So if you start thinking about it, it's not hard to remember 2001:DB8:1010:6lab or 61AB. It's not that hard anymore. That's just as easy as 10.10 was. Everybody's like, really? Right. What planet is Jeff from? Right? It really gets a little bit easier as you go through it. So 64-bit network, 64-bit interface ID, and we use basically a CIDR notation concept. All right? The /64 is the prefix link. That is the standard definition, and that is the way most endpoint operating systems work. Now, 64-bit interface ID gives you 18 billion possible addresses. How many have 200 nodes on an endpoint VLAN? 300 nodes. Come on, raise your hand. If you got some 400, you got like a 500 node VLAN? 1,000? Who's got like 1,000 nodes on a single point VLAN? And does everybody else start getting that cold shiver up the back thinking, broadcast storm, right? 18 billion. Are you going to re-architect your entire network to a single flat layer 2 domain? No. Never, right? So, do you think that 18 billion possible addresses, you're going to use, say, 200? Do you think the leftover is wasting addresses? Who says you feel like that's wasting addresses? Come on, be honest. We call this V4 thinking. Free yourself. Let go of the old days of V4 conserving addresses down to the drop of water. Okay? You take a /24 and you break it up into a pile of /30s to do point-to-point links, yes? And then you take 24s and you go, you know what, I'm never going to have more than like 20 addresses on there. And then you start carving up these V4. You carve up these, even network 10s. You carve them up into small pieces. Free yourself. You don't have to do that any longer. All right? There's no waste here. And if you try to do it differently, the operating systems aren't going to let you. Because the standard says the smallest usable network is a /64. So don't blink, don't think, just be happy and do it. All right? Out of the 340 undecillion possible addresses, IANA, who controls the address blocks, has only carved out 3% of the possible addresses in V6 to be allocated to the regional internet registries. And they haven't even begun to scratch a dent or a scratch mark in the allocations. And IANA is not even done yet with that. Don't worry about it. Free yourself of that old style thinking. All right? You're probably not going to re-architect physical layer networks because of what you can do with V6. You're going to layer V6 with V4. We call that dual stack. All right? And so you're going to keep them all. But don't get hung up on, I got all these leftover, I got all these extra addresses I'm not using. I'm wasting addresses. What are you going to do? Free myself of that thinking. Purge that old thinking, all right? Your life will be so much better. It just will. Now, in the V6 addressing and usage, we have a couple of shorthands. Because if you're like me, I'm not a really good typist. Anything I can do to make myself less typo capable, I will highly accept. So we can do a couple things. One of them, the easy one, is called leading zero compression. I mean, you can drop leading zeros. And don't do like a guy that I emailed with today. He dropped his post zeros, thinking that, I can drop any zeros. No. You can drop leading zeros. When you have basically 2 or more hextets contiguously of zeros, you can drop that down to a double colon. What you can't do is double colon twice. Because how many bits are represented in this double colon and how many bits are represented in that double colon? All right? You don't know. Because the actual RFC says you can drop 1 hextet of zeros to a double colon. It's not considered a best practice, but it's a quote, legal practice. All right? So in doing these compressions with this addressing schema, you can do it once, like in the option 1. So I drop these 2 hextets here, drop the leading, and then in the 5th, 6th, and 7th hextet, I drop leading zeros, right, down to a single in each hextet. Or option 2, use the 2 leading zeros here, or N zeros, and then drop the 3 hextets. If you see a question from a perspective of which one of these 3 addresses is a correct representation of an IPv6 address, the long one, option 1, or option 2, or D, all the above. All the above are legal representations. Any operating system should accept it in any of these kind of modes. Some operating systems, you enter it in longhand, they'll display it in short. Some you enter it in short, it'll display it in long. Oh, and by the way, alphanumeric, or the alpha characters, uppercase or lowercase, which matters? Upper, lower, or it doesn't? It doesn't. However, the best practice is to use lowercase. Cisco iOS displays it in uppercase. It's still valid. All right? So in any of these things, just kind of understand some of these shortcuts and why all of a sudden that address looks shorter. They're using these compression techniques. This isn't incorrect. This is an absolute. All right? You get a test question, is this a correct representation of a V6 address? The answer is no. I have yet to find an operating system that will allow me to do that. By the time you get that second colon in there, the hand comes out of the monitor, whack, you can't do that. All right? So, when you start looking at this stuff in Wireshark, these things help. Wireshark displays it in shorthand notation. All right? In V4 compared to V6, there's one critical thing that we don't have. We do not have broadcast traffic in V6, period. Everything that you know about as a broadcast type traffic in V4, it is a link local multicast or a multicast on link. All right? It goes to a particular reserved multicast for an on-link communication. So if you say, well, my V6 is broadcasting, you're done. No, your V6 is not broadcasting. All right, there's no broadcast traffic. It's pretty much local or multicast, something multicast. So that tends to look a little weird. We talk about the scope of addresses. In V4, I talked about the IPV address. All right, it goes away when it gets a quote unquote public or a route capable address. All right, in V6, that address is known as the link local. It never goes away. It's not routable. It's a specific reserve. As soon as an interface is enabled for V6, a link local address is automatically generated, and it's always there. That's your first V6 address that you will always have on an interface. If you want to have a route capable, since link local is not routable, then you need either a global unicast, which we kind of know as a public address in V4, or a unique local address, which is like the old RFC 1918 concept. They're routable, but unique local is not routable out of your domain. No ISP should accept your routes if you so send them. Neither should you accept routes if an ISP messed up and started trying to send them. All right? It's routable within your world, your domain world. All right? So you'll always have a link local. You will have one or more route-capable addresses within the same network prefix. We don't have that concept in V4, all right? You can sub-interface some V4 devices, right? Secondary interfaces, sub-interfaces, but typically there are different networks. In V6, you could have upwards of 4 route-capable addresses in the same network. And then you have to find out which one of those 4 you're going to use. Most of the time, it's not the one you think, all right, if you've got that many. So a couple little things that just continually start looking a little bit different in V4, or excuse me, in V6. So a couple of the reserved addresses, and my most favorite one right now is the : 1, basically the local loopback. So if you remember the old T-shirts and signs and stuff said 127.0.0.1 suite, 127.0.0.1, you know, the home sweet home. Now it's : 1 suite : 1, home sweet home. All right, that's pretty easy. Your link local address here, 169.254 in V4, FE80 : upwards of 64 bits, or at least 64 bits worth of space. That's your link local. That's a reserved prefix. Your route capable addresses will start with either a 2000 or a 3000. Right now, we're seeing only 2000s on the global internet. There was an old 3FFE address that was called the 6-bone, which was the original IPv6 test network in the late 90s, early 2000s. It's been decommissioned, and they returned those addresses back to IANA. So we actually shouldn't see any 3FFE anywhere. Everything would be pretty much in the 2000s. The unique local, like into the RFC 1918, it comes from the FC0700 range, but they're assigned from the FD00 in that link local. And then we have this reserved documentation address. So the types of addresses you'll start to see, we'll tell you very quickly what are they. FE80s, link local, not routable. Pretty much any 2000 is route capable. FC or FD is route capable only in your world, in your domain world, your network world. Even a 2001 is routable, but only inside. It's not a publicly routable address. It's reserved. You should not put that in production. That should be like lab testing. It's really used for documentation, exampling, et cetera, like that. Now, the interface ID in the original specs was generated based on the MAC address. Part of the V6, or actually the IP&G system was, we would like to be able to plug up a bunch of devices. They would self-generate an IPv6 address, and they could communicate, all right? And the initial bit was, how do you come up with a unique address per device? Oh, we'll take the 48-bit MAC address. How do you put 48 bits into 64 bits? Very, very carefully, right? There was an existing IEEE standard known as the UE64. Take the 48-bit number, split it in half, pad it with FFFE, you got a 64-bit number. But the guys decided, you know what? We would like to know that this is a uniquely generated for IPv6 use. So they took an unused bit 7 in the first byte, and flip it. And so when you do these two processes, you get the modified UE64 format, and now I've got a 64-bit address that was uniquely created for IPv6 use. You add this to the FE80::, and now I've got a unique number. And they should all be unique between each device, assuming, in this case, the MAC address is unique. Now that was the good news. The bad news was a lot of people said, if I'm the bad guy and I get on that network and I do a quick little scan of just FE80 type addresses and go to the offsets to look for FFFE, I can reverse those addresses that I get, reverse the 7th bit, I can find the company OID. Oh, go to the IEEE website, that's assigned to HP. Go to the HP website, oh, that's assigned to printers or desktops or servers or whatever else. So now the bad guys can find tons of information with a little bit of effort. So Microsoft spearheaded a way of, let's, as an option, use a random number generator to generate a 64-bit number. Woohoo! And they turned it into an RFC. And it is up to any particular manufacturer that uses this process to use whatever algorithm they choose to generate the 64-bit number. Microsoft take the MAC address, do a hash, do a something else, do a computation, and generate an address, which means you can reverse engineer it. So they save, what, 3 seconds for the bad guys? It takes them 3 more seconds to do that work as opposed to the MAC address. But nevertheless, we have a random number, so at least you can't look at that host ID, the last 64 bits, and go, oh, FFE in the middle, that's a MAC address, most likely, right? Because the chances of the random number coming up with FFFE in the same place is probably a little less, especially when you got 18 billion or so, maybe a little bit less than that combinations. The other thing that they came up with in this whole concept of the privacy extensions was, let's generate a second address, hopefully using a different algorithm, of course, but we call this a temporary address. And this address will change on a periodic basis. It's up to the manufacturer to choose that periodic basis. And now I use as a host that temporary address to communicate. I'm secure. I can't be found on the same address all the time. Think that's a good deal? Sure. Except for when you're Wiresharking between that client address and the server. And you're rolling along, you're watching the trace, life is good, and all of a sudden the trace just stops. Packets are still rolling, but you don't see those two things talking anymore. So you run to the client, because we're going to blame server or client still. It's not the network. Network's always up, all right? And you go find out, oh, the client's still going. They just got a new temporary address, all right? And it's possible because there's an extra timer that's now been added into V6. In V4, we had a timer of every address known as the valid lifetime, all right? They were considered from a DHCP perspective with some amount of time, statically configured, they're infinite. In V6, they wanted a way to not only address a network, but to automatically readdress a network without anybody involved. How many have readdressed a V4 network? Is your basic process, you send out the email, the global email Friday. Everybody, please turn off your computers before you leave. You don't say why, because if you give them any more information, it's just going to make matters worse. And everybody comes in Saturday, we rock and roll on the network, the server team does their bit, network team does their bit, desktop team does a few little things. Somebody makes sure all the printers are fixed, because they're statically assigned. We leave Monday morning at 2 a.m., somebody gets to stay to field a couple phone calls, and the sky falls apart because all those secret squirrel machines that nobody knew about, or the people that didn't turn off their machines because they weren't there to read the email. Does this sound like a more or less pretty good picture? All right, the V6 way with this extra address is, the preferred lifetime means I can communicate for X time. At the end of that X time, I still have some of this valid time left. I can finish up my existing communications, but I can't initiate new communications. I will then, as a client OS, ask or try to obtain another address. If I get a new address, I'll start my new communications on the new one, finish up my old ones, and that's why the Wireshark trace just went dark, because they started on a new address, a new automatically generated address, while they were still talking the other way. So now all of a sudden everybody goes, really? That temporary address is not what I want to play with, right? most operating systems allow you to either turn off that temporary or either that. Some don't even use it by default. Some you can turn it off if it's a defaulted on. But it's based on this whole function of auto-configuration, address auto-configuration. So all these things come into play. In the v4 world, when we talk about things like I need to do ARPs and you've got the ARP caches and all these good things, they're actually all those functions and protocols are spread across multiple RFCs. In the v6 world, they're all consolidated into one called the Neighbor Discovered Protocol. So if you're trying to do an ARP for another computer, then we do a neighbor solicitation in v6. The reply is a neighbor advertisement. If you want to find a router in your network, you do a router solicitation and a router replies. Some of these things we don't really deal with in a v4 world, like this router business. We don't have a concept of this. In v6, everything that a client does from an addressing standpoint is based on this router advertisement that comes out. It tells the client how they do this automatic addressing. This starts to become really, really critical. In v4, how does a device know its default gateway? Either through a DHCP scope as a field, right? Or manually assigned. In v6, you don't do either. It's all about the router advertisement. All right, the router advertisement, part of its field is, I am a router for you. In DHCP v6, there is not even a field for default gateway. So the network guy is going to build their list, say, here's their addresses, here's the scopes, here's the DNS, here's everything else, and give that to the server folks, and server folks will go, dumb network guy, you didn't give me the default gateway. And we're going to say, silly server guy, you don't need the default gateway. That's the Obi-Wan way. You don't need the default gateway. My router advertisement's in charge of that. So they're going to go, no, I have to have it. You don't need the default gateway. There's not a definition for a default gateway in a DHCP v6 scope today. It's a heavily debated argument right now. The server folks want it. They're lobbying to get it in there. Yes?
Quick question. If two routers are in one subnet and they both need to send that RA, which is better than the other? How does it determine which one to use?
Excellent question. Multiple routers on a network. Both of them tell me they're my router. Which one do I use? It depends. Right? Networking is all about nailing Jello to the wall. The longer you cook the Jello, the longer it'll stay, and the more nails you use. Go look it up on YouTube. There's a bunch of YouTube videos on this. Unbelievable. All right. There is a field in router advertisements, a preference field. So you can actually set the preference. If there's no preference set, then there is basically an address selection test. So the most closest match of my global address, my routable address, to a router's address should be used. But in theory, I've got two ways to go. Two different routers that I can use. It's not necessarily indifferent to the way we think of today. DHCP, a lot of people give out two routers. If they're not doing any kind of router redundancy protocols, right, they might give out two routers, .1, .2, .253, .254. You know, it's the secret for every network. Who uses .17 for their router ID? for their router. No, we don't, right? We use those others. So there's a couple of pieces, but that is actually one attack vector that you can have now is rogue router advertisements. So there's actually an RFC with a security definition known as RA guard that most of the router vendors implement, and you basically define trusted ports for router advertisements. All right? It's not absolutely going to block everything because there's ways around it. You know, the bad guys, as soon as one thing comes up, the bad guys find 5 ways to get around. But there is some ways of doing it. So we kind of have these things that are a little bit different in this neighbor discovered protocol mode. This router advertisement is really, really key. These, from the perspective of some of the messaging in this neighbor discovered protocol, these are the 4 key ones. All right? When you're going to build Wireshark capture or display filters, you're going to look for these IPv6 types. 133, 134 for the routers, 35, 135, 136 are for the basic neighbor discussion, neighbor communication. I could be talking to a router at quote, neighbor communications, but if I want to find out if it is a router or have a specific discussion, then it's a router level communication. So we'll see this in my examples. This particular chart tells you what flags or what bits in the router advertise, but there's 4 specific flags that you have to know about based on how I can do my auto addressing functions. The default out of the cardboard box is the routers are going to do this function known as SLAC, Stateless Address Auto Configuration. Routers, for the most part, V6 routers, for the most part, are set for that. Client operating systems are also set for that. The router gives the client the network prefix. They generate their interface ID. We don't need no stinking servers. All right? We don't need anything. What you don't get is any kind of DNS information. So you got to manually configure DNS and domain name. That doesn't really work in today's world, right? Who's going to go out and do all that kind of work? So we have what's known as the stateful address auto configuration, or DHCP-V6. It's likened to V4, but it's a different application. But you have to turn off a particular flag at the router and turn on a particular flag. And the router documentations are really good about saying, oh, you want to do DHCP-V6, go turn on this flag. They don't really tell you you should go off and turn off another flag, because if this flag is on and in this case the M flag is on and the A flag is on, you've got 1 linked local and 3 possible route capable addresses. And most everybody is going to think that I'm going to use the DHCP-V6 number as a client. And if there's a temporary address defined, that is the one that gets used because that's the standard. So the key of this particular chart is, depending on what you want to do, this is how you set the router advertisement up. All right, the particular flags. So this is another one of those things. When you're starting to troubleshoot, you will look at these flags. You're going to see this in a few minutes. Yes?
So maybe you'll get back to this a little bit later, but I was in a bit of a heated online debate with somebody about how Slack works with and DHCP-V6 works with regards to the prefix, your scissor for a given network, and I read that it was 64 or die. It doesn't work unless Slack doesn't work unless you have 64, and therefore DHCP-V6 doesn't work unless you have a /64 mask, because that's how it's defined. But then they were kind of countering me, trying to do that. John, can you give me a little insight as to whether I was not correct or whatever?
Let me see if I can restate an answer.
Okay.
All right. In either case, Slack or DHCP-V6, it's a 64-bit prefix, and the 64-bit host ID is either generated by the client in Slack, or in DHCP that comes from the scope. Period. Okay? Some DHCP-V6 servers don't even allow you to change the prefix link. Microsoft's, at least in Windows 2008, 2008, doesn't even allow you to play with the mask stuff. Right? Slack is pretty much the same. So it's always 64-bit network.
And does it define RFCs or?
Yes.
Okay.
So the prefix is always defined by the router?
On an endpoint network, yes.
On an endpoint?
Yeah. Yeah, in fact, again, you're going to see this in this router advertisement coming up.
Okay.
We'll see the prefix at 64 bits. All right? So it is. Now, can other operating systems, and I'm going to kind of point towards Linux, kind of a generic, maybe do something different? Quite possibly, but it may not work. Will router operating systems allow you to play with the slider mask? Some may, but the clients aren't going to work. So it's one of those, for the most part, leave it alone. Right? There is a provision for router point-to-point links to not be 64, to be 127. However, not all router operating systems allow that. So the rule of thumb for point-to-point links in V6, assign a 64 block, configure it 127 if you can. Because otherwise, you give it a 64, now I've got 18 billion addresses to do a ping pong attack. So the router vendors are getting better at this 127 support, but for client OSs, server OS, anything I consider endpoint /64. And most are hardwired. And some guy was trying to play with Microsoft's DHCP server, trying to get in and do registry hacks, And then it's like, well, fine if you can do that, but your client OSs aren't going to work. So, yeah, that's basic fact. All right. There may be some little exceptions here or there, but not very, very many. I'm spending more time. What time do I get to go to? 3:30? Something 30? Okay. I think I'm almost done. In V4, we know the acronym is DOOR for DHCP. In V6, it's called SAR. Basically, the router says in their advertisement, in flag is set, client request for a DHCP v6 address. So the client sends out a solicit message, okay? The server says, here I am. The client says, hey, can I have an address, please? And the server says, here you go. That's the shorthand version, all right? But it's a familiar process. You have DHCP v6 relay just like you have DHCP relay or helper addresses in the v4 world, all right? So the setup is almost the same syntax or same verbiage. I'm going to let you guys play with DNS later. Quad A records are for v6, A records are for v4, and on. So, okay with v6 for the moment? Yep. All right, good. So, Wireshark, everybody knows about Wireshark. I'm going to blast past this. All right? A couple of things. Who uses colors to help them? Who thinks colors are a nuisance and you turn it off as soon as you possibly can? Fair enough. All right? I became much more of an embracer of color feature for v6 because the traffic is flying by. Router advertisements, I want to know those occur sometimes. They're supposed to occur frequently. The frequently is a timer between 6 and 10 minutes. Or every time a client comes online, they'll do a router solicitation, the router sends out an advertisement reply. All right? But I want to know those things happen, but I don't need to know anything more than that they just happen. So I give them a color to help my eyeballs go, oh, wait, there went a router advertisement. Good. Now, if I see a whole bunch of router advertisements go by, then I start to wonder, do I have too many routers? All right? So everything's relative in this world. So colors may help. And we talked a little bit. That's kind of my base. The other thing I do is I get rid of the packet bytes display window. Because to me, that's just visual noise. It's in the way. I don't get into the packet bytes till I finally figured out there's the packet. Right? So I just turn packet bytes off from my perspective, make life a little bit easier. So the color rules in this particular case, I have orange set up for router advertisement. ICMP and ICMP v6 traffic, which makes up a whole bunch of traffic on a regular network, in Wireshark are the same color. And so I actually go through and modify, and I'll show you that here in a few minutes. But colors I tend to find, especially for my v6 lab testing and v6 production testing, help a lot. So I made a couple of different ones. I've got router advertisements in orange. I've got router solicitations in pink. And then, because ICMP was this same kind of light blue, I built a new rule to make my ICMP v6 traffic yellow. Pick colors if you choose, but when you start playing with v6, it helps to see the different color traffic flying by. In fact, go back on any of your local segments and just fire up Wireshark to see how much v6 traffic you have in your not v6 network. Because it's there. Oh, how many turned off the v6 protocol box in Windows? Did you run a trace after that to see if it really did turn it off? Did you go read the Microsoft registry thingy that you could do from 4.5, 5 years ago? And that didn't really turn it all the way off. You kind of sort of can't turn off v6, right? It depends. It depends. But set up some colors. You can play with the colors. I don't have to deal with that. Packet view, I talked about that. Columns. Some of these things you guys might know. You can go back and read on this. Display filters. How many use display filters? All right. That's a pretty good thing. There are a few predefined, and so since we got a lot of knowledge on display filter, that's good. I'm going to go to this. In the current 1.12 up to the 1.12 family, there's 3 predominant v6 filters in Wireshark, display filters. All right, IPv6 is everything, ICPv6 is some, and DHCPv6 is just that. Easy enough. So you type it in the display filter and go. At some point in time, you're going to probably want to tune a little bit and not only build display filters, but you can save them once you build it, and then you have your pickup. All right? So if you start playing with V6 in the lab, there's things you want to know, like the router advertisements occur. You'd like to follow the DHCP-V6 traffic. Typically, you actually want to look at router advertisements and DHCP-V6 together, because a DHCP kickoff should only occur when a router advertisement's M flag is set, and a client sees that. Now, a particular bit of info. If you're familiar enough in the V4 and Microsoft's Windows products, when you just turn it on, do they get their address from DHCP or from manual? For V4, Microsoft Windows, you just turn it on out of the cardboard box. Is it going to try to DHCP for an address, or is it going to be a manually configured? It's going to try DHCP. Everybody agree?
Yep.
V6, it's the same set of bubbles. However, if you go into V6 in Windows and statically configure an address, and the router advertisement comes through with an M flag to tell that client OS, go get a DHCP V6 address, how do you think Windows reacts? Do you think it not asks for a DHCP V6 address from a server, or do you think it will? It will. A client OS that's V6 enabled is supposed to do what the router advertisement tells it, period. So in Windows, if you manually configure a V6 address, you want to turn off the M flag and the A flag in the router advertisement. Otherwise, it will do either one of those because it was told to, and it's supposed to.
And so
All right?
in that case, then, does it predominate? So, I mean, you've configured it, and then it goes out and says, give me some love. It gets the DHCP. Then as you watch traffic on the wire, will you see only that one that's provided? Or does
Not
it get...
necessarily.
Okay, that was okay.
All right? You could possibly see either. Part of it depends on the address selection process. Are we scared yet about this V6 stuff? Say no. I'm giving you all the good stuff right now. You got the meat of it. You've heard it. They're recording it, maybe. It's not connected with an RJ45, so I got no clue, right? It's not network connected, so I don't guarantee anything. I'm not the audio guy, I'm just a network guy. But yes, those are the things. If you start playing with V6, don't turn it on, quote unquote, in production and then start taking traces. Or if the only network you can do it on is your production network, do it off hours. You need to try these things. Don't just do what you want. You need to try these other things because somebody else that's involved may not know what to or what not to do, or may not understand. Or some pesky user, did I say that right? Has admin rights to the computer and goes and makes a change. So you need to run these kind of scenarios and Wireshark it, right? And get the trace to see what's going on. Because it will tell you exactly, right? Because what do the packets not do? They don't lie, right? So you, in setting up colors like this, it tends, in my humble opinion, to make life a little bit easier when you start very specifically looking for Wireshark. And or looking at packets with Wireshark. And then build configuration profiles. Who uses those? Okay? I find as I go through time, I love it more and more all the time, right? Because I can build a profile for whatever I want. And it gives me just that view, gives me colors, gives me display filters, gives me columns, gives me everything that I want. So I find those things. The last thing, 2 comments. A question first. How many have network diagrams of the network, more or less? And have more red ink than toner ink on it? Or some other color ink, right? So you've marked it up because it's changed since you last printed it. All right? How many have good traces of the network in the good days when nobody's complaining? Then how in the world can you troubleshoot a network when you got no baseline? All right? So the first baseline you get is the first network bad set of traces while you figure out what's going on. Go in with packet annotation, with the packet comments, and make comments in those traces. Oh, here's where it started going bad. Here's where we found the problem, server team. Here's where we found the problem, applications team. Here's where we found the problem, network, delete. We ain't leaving no history to get blamed on that one. No. Use your packet comments. If you're getting good traces, use your packet comments to denote these things. when things good occurred, when they started, when they stopped, when the results, okay? Then use it when you get the bad stuff as well. It can help a lot. If you're doing your first bit with V6, it helps immensely to make some of these milestone markers. Hey, this is a router advertisement. It's the first one we saw, or this was a reply, or this was a this, or this was a that. All right? Use some of those features. And then we talk about all kinds of resources that are available. Let me bounce into Wireshark right quick. So default setting of Wireshark, and I'm going to go straight to my IPv6 setting, one of, and it gives me lots of different things. Predominantly, all we can see right now, I've got all these different display filters. Very quickly, if I want to find router advertisements, there's my router advertisements. If I want to look at the router advertisement, and let's start talking about those key things I was saying. Network, here, prefix information, all right? Right there is the 64-bit network prefix. Now, will a client use this prefix as part of configuration? Depends on this A flag being set or not set. It is not set here. All right? So right off the bat, I know that this router advertisement is not set for the Slack function because the A flag is not set. It's turned on. So what would be my other option if it's not for the Slack? It would be the... Got to have a server guy involved now. But I get to have the control if I want the server guy involved. But I got to go up here to the flags. They're a little bit higher above the prefix information. And I see that this M flag, stand for managed address flag, is on. So a client that would get this router advertisement would then ask for a DHCP-v6 server help. Period. All right? Doesn't matter how the client at default state is configured. It's supposed to follow this rule. Yes?
If the client has something configured manually and they don't receive a reply, so they got a manually
Yes.
configured address and it says go ask DHCP, they ask DHCP and then crickets or something incompatible or whatever, do they maintain what they had before?
They'll keep the one they had before. So the fair question, if I don't have DHCP server, let's just say,
Sure.
or it's not reachable for whatever reason, but I have a static address. Static address will get used. However, how does the client know about a default gateway? Through the router advertisement. So as long as the router advertisement still occurs, and typically with that, the L flag down here is set, that kind of tells the client, I'm your router. If you find an address from a DHCP server, great. If you have your own address, I'm still your router. What if the RA never comes and a client's got a manually configured address?
Doesn't know the gateway, right?
Some operating systems allow a manual configuration of a router. Windows does. That should not be used. That is not the proper use based on definition. It will work, but what if the router address changes? You can't change it through DHCP, right? You can't necessarily change it because the router advertisement has got that hard-coded address. So you shouldn't hard-code the default gateway in client OS, even if it allows you. You should not do it. Because if the router is in control, the network is in control, man, it's ours. Yeah, it's also ours to mess up really, really bad. But we're not going to let them know that happened. We're going to fix it. Okay, here and then to here.
So the notion of IP helper, you mentioned that in passing earlier. So routers, if they're going to advertise, then that assumes that they have this helper notion for forwarding that DHCP request
Correct.
to a place that can provide.
That is correct. And that is something you have configured, quote unquote, just like before.
Sure.
You do it on the same interface. Depending on the syntax of the OS, it's either a one command or a two command.
Got it.
In V4, most router products or route capable products have DHCP relay as an enabled feature. You just have to give it the helper address. Most of them for V6 don't have that case. So some, it's all done in one command line. Some, it's a global helper DHCP v6 relay, and then not a global helper, a global DHCP v6 relay, and then an individual router interface helper, v6 helper address. But if you have the same concept, yes. Right, you have to turn on. Yes, sir.
Now, if I'm a V6 client and I find out who my router is via a receive RA, and then when a DHCP V6 response comes back to me, I go, man, make my request. If the DHCP was my next hot router
Right.
is with the received RA.
Correct. That's why I say the network team, when they get that stuff from the server, or from the server team, when they get it from the network team, they go, stupid network guy.
But that also means it's real. That's one of those really different concepts of
Yes,
V4, V6.
absolutely.
That we're all used to V4, like, oh, that's
Yeah,
right.
and like I say, it's actually being discussed at the IETF that maybe they changed that behavior. But just because they would say change doesn't mean all the operating system people are going to change. Trust me, there's already been a few things that Microsoft says that, no, we're not going to do it. We don't care. Even through Windows 10. Yeah, it's not, we don't care. We don't care. Hang on, I have to say it. Android does not support DHCP-v6. It's a heated battle, discussion going on. And apparently it's like one Google software engineer has the control and he just says, no, we're not doing it. Now so therefore the only option is like Slack. But Slack doesn't give you DNS and domain name info.
So now Google's just down the road over here. We can like go slash is tired or something.
But I mean, there's some things going on even at the manufacturer level. So hang on, you're number 2, yes sir?
Yeah. So you had mentioned the so you can be in whatever state, and then you get an RA, and then. Well, so I guess the first thing is so let's say you did the normal thing. You get an RA. It tells you to go to DHCP. So you go to DHCP, and you get your stuff, and you're rolling with that. Are you still listening to the RAs?
Yes, always.
So is there anything in place in the OSs to stop them from just
I get
listening?
one, ignore the rest. I don't need to listen to the RAs anymore.
No preemption.
No.
Okay. So there.
No. In fact, I do demos where I'll have router 1, router 2 with different timings and polar opposite configs, and the clients bounce back and forth.
Is there?
Oh, it's awesome. Oh, and wait, it gets better. Microsoft chose an algorithm for recomputing the random addresses differently than Apple. Bipolar differently even. Microsoft says, I compute an address, I write it to soft registry. If my interface doesn't go down for 24 hours, I'll ask for the same address again. And then I'll do that process for 7 days. And then finally, I'll completely regenerate. If the interface goes down, power down, disconnect, turn off the port, okay, it all starts over. Apple asks every hour for a new address by default.
Because they're used to being chatty like Apple Talk, that's why.
Say again now?
They're used to being chatty like Apple Talk.
So, and most operating systems allow some changes and timers and portability. But again, it's some of those things. You are supposed to do whatever an RA says,
So,
no matter how many RAs you get.
Is there anything? So that's going to go out across a subnet, right? Across a set of switched interfaces.
Yes.
So is there?
Well,
is there,
8 per routed interface.
Sure, but let's say you got a routed interface, and so that's it, a VLAN or
Yeah.
whatever.
Yeah.
Is there anything like? I'm thinking of something like spanning tree kind of thing, where you could have a BPDU guard or something where you can go on your switches and say RAs only come from here.
Yes, that's called RA guard.
Okay.
And you define the trusted port if your switch OS has that feature.
Yeah.
If it's route capable and doesn't have the feature, then you just build an ACL to do the same kind of thing.
Plugs their compromised laptop into the thing.
Yeah. There is some security mitigation. It's not foolproof, but there is some security mitigation. Yes.
So you're in the middle of your trace. You define the endpoint that you want to look at. You put a filter in there for it. You're going along just fine. Life goes dead because of the renegotiation. How the hell do you compensate for that? I mean, is there anything automatic that tells you, oh, by the way, it went here?
No.
It just leaves.
It just happens. And you wig out the first time, you go, we found the problem, it just stopped. We can figure this out. And then you go back to it, still crunch along.
Or would you
Now,
would you teach?
some people, and let me rephrase it, most OSs allow the capability of turning off the temporary address. Okay? And so therefore their randomly configured main address doesn't change unless the interface goes down. All right? As long as it's up to spec. For that very reason. Because they don't like that feature, that pseudo security feature, the temporary address, changing if I have a troubleshoot. All right, so you can generally turn off. Server OSs typically have that turned off by default.
But there is no way to automatically hear, oh, this took place,
No.
therefore.
No.
So when it gets the new address, is it the client picking the address, or does the router tell it what its new address is going to be? So there's not a packet that goes across that says you're moving?
Well, there is, it depends. It depends on how the address is generated, whether you might see a packet. If it's DHCP generated, you might see basically either a request for a DHCP server, or you'll see another type of packet called an information request. I mean, there's a couple of things you could see, but not if you're just doing a point-to-point trace.
Right.
Especially if the DHCP server is not the same server you're doing a point-to-point trace.
Because you'd have to hear that command and control stuff going on there as well as the point-to-point.
Exactly.
So you just
exactly.
needed 4 at the end of all your rules?
That's why I make this comment. If you kind of look at my names up here, I've got an RA, and then I've got DHCP6 and RA as another filter. Okay? Because I use the RA one right now. Do I have router advertisements? Yes or no?
Oh, yeah.
Okay? The answer is yes. Do I have router solicitation messages? I had one in this particular trace. But do I have, with typically a router advertisement, you will see very quickly, quote unquote, see very quickly, DHCP solicit messages come through, or renew messages come through soon after the RAs. And when you filter it this way, they're kind of like this. Now, it depends on the number of devices. These are very small lab scenarios. But still, building a display filter for real time, showing this stuff up like this is great. All right? And this is where working with V6 and Wireshark and understanding now maybe some of these things, you get this extra power with Wireshark. And I think we're here and then there.
Just to follow up on the edge node watching and place the address, could you do the capture against the subnet to watch your address swap?
Subnet?
So
Potentially.
right.
It just depends on how you're detailed the troubleshooting as to what you're going to see. Very honestly, they seem to be, I won't call it best practice, but the seem to be used practice is for now to do turn off that temporary address function through group policies if it's Windows World, all right? Because not even people need to do a lot of it. It's when you need to do it. It's going to be all that extra grief. And so a lot of folks are going to, yeah, you know what? If my network is so unsecure that people are finding me that easy, that's a whole other problem that needs to be resolved first, right? Yes, sir.
But the temporary address is, not using a temporary address means that your computer can be tracked from site to site to site to site, right? Because your MAC address gives them perfect visibility into which computer is browsing.
Yes, but the temporary doesn't have the MAC in it.
Well, exactly, but if you turn off the temporary, then people can track you on the internet perfectly without having to resort to browser tricks because you reveal yourself in your IP address.
The temporary function is being used, the other one's a random number.
That's why the Chinese designed it, okay, come on.
No, but that's the problem, is turning off the temporary makes you extremely trackable.
No. The temporary is only good, well, I would say the temporary won't follow you unless your network connection is
Right,
up.
but your EUI 64 makes you perfect.
Oh, absolutely, and that's why people don't like
your
it.
second-
Microsoft does not use the modified UE64 by default. They use the privacy. Apple, at least through 10.9, still use the modified UE, but you can change that behavior. Linuxes use, again, it kind of depends on the flavor, more of them are still using the modified UE, but you can change that behavior, all right?
Right.
To the more random, and then maybe turn off the temporary.
Right, so I mean, the thing is you have to have a hard choice to make, right? If you keep that.
He's saying that you can do both. You can not use the MAC address and not use the temporary.
Right,
You can
But
use
still
it.
have the random
But
generator.
no matter how obfuscated your second 64-bit is, it's always yours.
It's
If you turn it off so it never changes. So when you hit me from
Oh, no.
the new one, it
The
will
only
always-
time the mode of it never changes if it's the modified UE64. Then it never changes. The random number generator, whether it's the temporary one or the other one, changes potentially every time the interface goes up and down. It doesn't change on the fly.
Oh, okay.
Like
Turning off
temporary
the
can
file.
change on the fly. Oh, that's right. The key is, my old temporary is being used for my finishing up, and my new temporary is being used for the start of the next request.
On the fly.
On the fly.
Whereas if I do it the other way, I have continuity through the interface. staying
Exactly,
up.
and for the applications to stay up. and it could be in the same network or different networks. So if I want to readdress my network, that's where I can change that prefix, finish up old business and start new business. If I just want temporary quote-unquote non-tracking, it's still the same network prefix, different host IDs.
But if I pick that PC up and I go to another network at another building, now I plug the thing in, my
It
machine
starts over.
address is different.
Yes.
And I have to keep that in mind, because if I thought I had a filter for it when it was back over here,
Exactly.
That's the key.
Exactly. If that computer gets turned off tonight, you come back in tomorrow and start troubleshooting again,
it's gonna be a
it
different address.
possibly will. Depends on the OS. Microsoft, because of some of the things that they do, may sometimes still ask for that,
No.
depending on where the register was left.
No, we take it for
But still,
granted is what
yeah.
it comes down to.
Effectively a move. Now we kind of have to factor wireless out, but effectively a move starts things off for the dynamic of the random number generators.
But but if you, like that, if you went from one building to the other, and you plugged into another one, they're gonna get a different RA for that building.
Yes.
But
Yes.
it's not even network prefixes.
They'll be on a network, and depending on how their interface ID is generated, it could still be the same interface ID, but they'll be on a different network.
Right.
Yeah, so whether or not your host 64 bits even stay the same, your network side stays the
Right,
same.
right.
It's
In
a
theory.
different 128 address.
Yes.
Can you filter based on only interface ID? I
Sure
mean,
you can.
interface ID and
Host ID, host ID.
Host
Through,
ID?
with Wireshark, just
Yeah.
look on that offset.
Yeah, you could do
Of course
that.
you could.
Are you
But
saying
if it
that you use the
changes-
offset? It's not like a simple thing. You have to tell it. Look at byte number, whatever. To byte
Right,
number,
right,
whatever.
right.
Oh, I see.
Yeah, I mean,
Instead of-
Wireshark gives you that. It's
It'd be
more
an
work.
option, like network. But anyways.
Mike Joe, man.
Yeah.
And then you better hope that you really are using 64-bit.
Right.
See, this is job
So
security. This is job security.
Thank you.
If it was simple,
Thank
they could
you.
do it themselves. We don't want
And
that.
embrace the coolness of V6. Embrace the fact that your peers are scared because they don't know the story like you know the story now. Embrace the fact that this is going to be way cool stuff. And it's about to hit more than we kind of think. And yeah, that's been said for the last 15 years. Aaron's down to they're almost out of addresses.
Yeah.
That does not mean the end of the world. But let's let the FUD component kick in to senior management. Aaron's out of addresses. We're going to go V6. Say yes, boss. Oh my goodness. This is way cool stuff.
It's like year 2000 on
It-
steroids here, baby. Year 2000 on steroids. Right?
Exactly. Well, they're talking about that. What's the leap second that we've got coming up?
June 30th, baby.
They're calling that the Y2K kind of thing, right?
2 a.m. in the
But
morning.
V6 unto itself, very honestly, I'll say, I've been playing in V6 for just over 5 years. And for about the first year, I could make V6 work on networking and stuff like this. Until I got into it deeper with Wireshark and understanding operating systems, both client, server, and infrastructure, and looking at traces and the nuances and the service packs and blah, 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 I did not know V6.
Right.
All right? There's these little nuance things, a lot of the stuff that I've brought up today, that it's not secret, it's just the nuances. All right? There's enough things in the RFCs to give some absolutes, and then there's a lot more that says you just have to do something within this bounds, like this random number thing. The timing of the random number generator. It's a bounded. You must do it. But nothing else to say when and how long and everything else. So that's why playing with V6 in your network, you need to do a couple of things. You need to just set up a few devices and just look at it. All right, we'll trace it, see how a few things work, and then try to mimic part of a real world network. A couple of network segments in some kind of a lab. Whether it's all virtual, I've set up multi-segment virtual networks in VM, Workstation, and VirtualBox, doing this stuff on an airplane, right? Geek, yes, I get it. But still, it doesn't take, quote unquote, a lot to necessarily start playing. Run Wireshark to see what the packets are doing, to see what the applications, to see what the operating systems, to see, wait a minute, how come I'm not getting any RAs? Windows 7 and 8.1 and probably 10 If the bubble is not selected for a static address, it's still set to its default DHCP, they also do DHCP requests without being told to.
So
Now, as soon as they get an address, they stop. But if you just fire up Windows 7 clients and fire up Wireshark, you will see these solicit messages. Solicit, 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 solicit. And if there was a DHCP-v6 server on that link, they'll get an address.
But
Now,
not-
generally, we think of our servers as I will call it off-link, right, on a server VLAN. And so it will die because you probably don't have relay turned on. But if you've got relay enabled, client sends out a solicit. It's an all points multicast. Well, actually, it's a link local multicast. Hey, I'm looking for a server. The router goes, oh, I know how to get you over the fence to the server. The server's got a scope defined for that subnet. They'll get it. And we didn't have the M flag on it. But that's only Windows, not the other ones. All right. So you want to understand these things, and that's where IPv6 and Wireshark can help you understand this. You have questions?
Yeah, how does it know what the prefix is? How does it know what the prefix is if it did not know what the prefix was from the RA?
Because the router advertisement, when the router sends that DHCP relay across, puts the prefix in just like regular DHCP relay.
Ah, it sneaks it in there.
Yes.
So,
But that's not
on
my
the way back, does that DHCP information have the prefix?
It probably has a prefix, but it probably doesn't have the gateway.
Yeah. Well, it doesn't matter about the gateway as long as the router advertisement still has the L flag on. The client can actually get stuff without having been told to do it because, in my humble opinion, Microsoft's doing it wrong. My humble opinion. They should not do DHCP unless they are told to. I personally believe, like, just look at it as a non-programmer or a non-whatever guy, they just copy the code and mimic the same operation. So therefore, if I know I've got Windows 7 clients, I know I want them to V6 and I want them to DHCP V6, you turn on the M flag. And that way there's no, what happens if a Mac shows up? What happens when Linux shows up? Legitimate, right? If they show up and they don't get an M flag, they're not getting on the network. Why are the Windows clients on the network? Because Windows goes ahead and asks, even though they weren't supposed to, or weren't told to. Okay? And then my favorite, again, with that demo is having what happens if you're rocking along doing some work, troubleshooting, whatever, and another router advertisement comes in, and the M flag is off. Depending on your version of Windows 7, where it's patched. You need Service Pack 1 and an IPv6 Service Pack. If they had a DHCP address and they get a router advertisement that says do Slack, they will immediately drop their DHCP address and get a Slack.
If the preference is higher?
Pardon?
If the preference
It has
is
no bearing on preference.
It's
Because the flag told them to do this, they do it. Mac OS will keep that DHCP address for the valid lifetime. And then it'll drop it because it's got Slack addresses. Oh, this is fun. And I'm seeing lots of eyeballs just getting bigger and bigger. Really? I'm not doing V6. A couple of the other old guys in the room are thinking, can I retire out before we enter V6? No! It's going to be okay. As long as you've got Wireshark, you got a little bit of knowledge.
Yeah.
All right?
Baseline.
And if you're not doing it on purpose today, now you got some time to play with it, some time to look at it, some time to do a little bit of the understanding.
Yeah.
At the end of the slide deck, I've got some reference books. Book I was a part of, one of Laura Chappell's books, more Laura Chappell books. Another Laura Chappell, another book Chris Sanders did on Wireshark, kind of a generic. A couple of other really good books to get. Address Planning and the IPv6 Essentials. Both of these are fairly fresh books.
Which is the one that mostly resembles how you teach us?
So, you know?
Which is your favorite one? The one that resembles mostly of how you're teaching us today?
That book still.
Of course, the one I was part of a team on.
Book, man.
You know, fine, shameless plug. The Guide to TCP/IP is a dual stack book. It's half V4 and half V6.
Laura Chappell was part of that one too, huh?
She was part of the early team. It's a textbook. It's actually a university course book.
Really?
All right? So it's half V4, half V6. And this is literally on this project 4 years ago is where I really learned about V6.
Nice.
Yes.
Ah,
Your question? Oh. The nice thing about this book and quite a few of these other books, at the end of chapters, there's like little questions. There's mini labs in some of them. But, you know, good books here, good books, good books. These two are really good books. Rick Graziano's book, he is a professor at a college not too far from here, a little bit in. He also does Cisco classes. So his book has a Cisco slant with V6. Ed Horley, who works here at an integrator in the Bay Area, wrote this book about 1.5 years ago. It has a Windows 8 and Windows 2012 viewpoint, but he also goes to GUI and PowerShell focus of managing and configuring V6. There's another book from Microsoft Press by one of the core beginning Microsoft V6 guys, Joe Davies. It's called Understanding IPv6. Okay? Any of these books that are within about the last 4 years are relatively current from the aspect of RFCs and knowledge. And obviously Laura's book, the book I was a team on, and Joe Davies' books also heavily with traces. Examples, you can download the trace files. Although Joe uses that Microsoft thing, not Wireshark. Right? Where all the rest of us, of course, use the good stuff.
Your book in Amazon.com is on sale for $107.
I was just part of the team, man. I'm not charging. All right. So if you're playing along and looking at this stuff, you know, again, use packet comments. All right. If you played with the packet comments, this just has some data. I didn't put much in here, but use the comments in your V6 early days as you're discovering things, especially if you've got multiple client OSs and you're observing more than anything else the address functionality behavior, the auto configuration address functionality in different OSs in a given trace. Make those comments. This is a Windows 7 client at this level service packs. Okay, Windows 7 native is really not the right one to use in a V6 world. You really want to use it with Service Pack 1, and there's an additional knowledge-based service pack for some very specific V6 fixes, or V6 enhancements. Probably said it right the first time, all right? Apple OSs, some of the different ones. They didn't even support DHCP V6 until 10.7. Now that's like 3.5, 4 years ago, but still, all right? In my mind, everything before that didn't matter. They didn't support it. That's not a real-world play. Most of the Linuxes do, but may not all have a DHCP V6 client or a little service. So you got to add the service into it. So play with those things. Fire up your Wireshark. Look at your traces. See the behavior. See what's going on. Annotate your traces. And help understand what you've got going on. Play with the router advertisement bits. Experience this. 4 addresses in the same network. Can you do that in IPv4 on an interface? Mm-hmm. You can't give it 4 addresses in the same network. I can't do 10.10.10.2, 10.10.10.3, 10.10.4, and 5 in Windows 7. You can't do that. Can't do it in the server OSs. I give them different network, same host IDs or different host IDs, but I can't give them up to 4 route-capable addresses in the same network. So get that in a test mode and discover when you do pings and when you try to go off-net, different addresses are used differently. They're all valid to be used. It's legal to have the configuration. There's no rules being broken other than life is going to be miserable if you allow all the possible capability. You want it to be in quote-unquote finite, right? You really want to get to the point of the link local that you can't mess with and 1 route-capable address. That's your best choice, whether it's a manual configure, a DHCP v6 configure, or the primary random number one. Turn off the temporary. And then you've got all you need. The link local you have to have. If you try to turn it off, on just about any OS, it turns off V6 or disables it perhaps. So link locals are always there, and you'll have a route capable.
Does it always use the link local if it's local traffic? Like,
Yeah.
does one host always use the link local as a source?
Generally, yes.
Okay.
Awesome point. When is the link local used? For all local layer 2 level communications. You communicate to your router via the link local address. So again, if you've got an interface set up and you look at the V6 default gateway or the V6 gateway, it's going to be an FE80 colon something, not the 2001 whatever address that we would think of like in the V4 world.
How's that work for like a firewall? Is the first hop, say like your default name is a firewall, it's going to show like the FE address?
Yep. Your first hop route. Where's your router? Router has to live on link. Here's the best part. Yeah, I got to stop. Here's the best part. Can a router or a layer 3 switch, well, let's say 4 interfaces for 4 different networks, can each one of those interfaces have the same link local address? Yes or no?
Yes.
Or why do you even ask that kind of question, Jeff?
Yes.
Yes.
It's all relatively different.
Because they're all link local. They don't route. They have no knowledge of each other at the link layer. So they can and quite possibly will have the same link local address if the self-generated mode of the using the modified
They
US64.
don't see each other.
Now most infrastructure devices, operating systems, allow you to manually configure the link local. And I do that because if you've got point-to-point static routes, you use the link local addresses. If you're using them based on the modified US64, you replace the router, put a new one in place. What's changed? The MAC address. So the other config is wrong and your config might be wrong. So if you give statically configured link locals in your infrastructure, then they've got portable configs. We're out of time. Thank you so much for coming. I hope you found it.